Okay, so introduce yourself.
Yeah, so I'm Shrestha Mukherjee. I've just completed my BSc in Statistics Honors from St. Xavier's College Autonomous, Kolkata. And I did my schooling from Barakpur Ramakrishna Vivekananda Mission. Um, and my hobby is recitation. I recite Bengali poems.
What
Okay,
is your
so
hobby? Recitation.
Yes,
did you appear for any other exams?
I appeared for JAM,
Okay, so what was your rank?
fourth.
Okay, so what do you think? How did you perform in PSA and PSB?
In PSA, I matched my answers with the answer key. So the marks was 103. And
Okay,
in PSB, I made some mistakes. It wasn't great, but it wasn't too bad, I guess. But I made some mistakes.
okay. So how many questions you have attempted in
I
PSB?
attempted 5 questions fully, but in
Okay,
two I have made some mistakes. And in another 3 questions, I just attempted the first parts only.
okay. So are you ready for the interview?
Yes, hope
Okay,
so.
so just be calm and listen to our questions carefully. So
Yes.
Shayan, you can ask question.
No,
Okay,
তোমরা শুরু করো, আমি আমি পরে করছি।
okay.
Okay, then Suvanjan, you start.
So, do you like statistical inference? Are you
Yes.
comfortable with that?
Yes.
Okay. So,
I like probability more, but influences also.
okay. So let's begin with statistical inference first. Then we will come to other topics and mathematics. Okay. So, what do you mean by a 100 minus alpha percent confidence interval for any parametric functions I theta?
Okay, so if I is 100 into 1 minus alpha percent confidence interval for a parametric function xi theta, then we can say that it is there is 9 alpha sorry 1 minus alpha percent probability. Uh, oh, can you repeat the level once again?
101 minus alpha percent
100 into
confidence.
okay, yeah. So the probability is basically 1 minus alpha, that this interval will contain the parametric function xi theta. If we break this down further, if we take repeated samples from the underlying distribution and calculate the interval for each sample, then in the long run, approximately 1 minus 100 into 1 minus alpha percent times this the computed intervals will contain the actual value of the parametric function.
Okay, so that's okay. So can you state me one good criteria for a criteria for a good confidence interval?
Okay, so a confidence interval should have a lesser length. The lesser the length is, the better is the confidence interval. So
Is that the only thing, or a lesser length confidence interval with a great coverage probability?
great.
Is it only the less length confidence interval, or a confidence interval with small length but a higher coverage probability?
I thought the coverage probability is fixed, as you mentioned, 100 into 1 minus alpha percent.
Yeah,
So,
that's good. Now, is confidence interval unique for a particular confidence coefficient?
no.
Can you give me an example?
Okay, so if we think of normal mu comma 1 distribution, then we can say that x bar, and we are taking 100 into 1 minus alpha percent interval. So we can take x bar minus plus tau alpha by 2 into 1 by root n. So that's one confidence interval, and we can take from the
Can you repeat once? Can you repeat once?
yeah, x bar minus plus tau alpha by 2 into 1 by root n.
Yeah.
So that's the confidence interval.
Yeah.
That's actually of the minimum length. And we can take the right part as well, like x bar plus tau alpha into 1 by 10 to infinity.
Okay. Is that so? Can you check it?
Okay, I'll just yes.
Okay. Now, so you have constructed two distinct confidence interval with different length, right? One is finite
Yes.
length, one another is not finite length, and keeping the confidence coefficient same. Now, can you construct me one example where, say, confidence coefficient being same, two confidence intervals you have to construct which are distinct, but the length is also same.
Okay.
Did you get my question?
Yes, we did. Mm. In normal, we can't formulate that kind of two distinct intervals.
You can use any sort of distribution.
Yes.
Do you need any hint?
I was trying with uniform. Uniform is 0 theta.
Why have
So
you chosen uniform distribution?
because there the probability is same for every point. So
Uniform, are you considering uniform discrete or uniform continuous?
I choose continuous one.
So how the probabilities are same across?
I mean, um, not the probabilities are same. Like if I consider the PDF, the PDF is same for all points.
I mean, it's easy to manipulate the length, right?
Yes. Yes.
By using
So
that uniform
even if
distribution.
we shift them, then
Perfectly
yes.
all right. You are on the right track.
yeah, one confidence interval is 0 comma theta into 1 minus alpha whole to the power 1 by n.
You are considering which distribution? Uniform what?
Uniform 0 theta for theta confidence interval.
Okay,
So
and you
one
and
is 0. Yeah.
okay, you are considering x is uniform 0 theta.
Okay. Just a minute.
You may even change that 1 minus alpha. That's not necessary. You can change. You can take 1 minus alpha as anything else between 0 and 1.
Yeah, getting in terms of time.
Try taking 1 minus alpha as 1 by 4. May I give you another hint?
At 1 minute, please.
Okay.
Please. I would like to have a hint.
Okay, so for uniform 01, can you think of two different intervals of length 1 by 4, but the intervals are different? You can easily construct that.
Yes. One is 0 to 1 by 4 and another is 3 by 4 to 1.
So now can you do that? Can you use that to construct two different confidence intervals?
Actually, I was taking the confidence interval as x order n comma k x order n. But in that way, if I want to compute k, that's coming in terms of theta only.
So how are you getting x order n? I have not given you any sort of sample. I have given you only one observation, that is x. X is
Okay.
0 theta.
Okay. Even that also, if I like, I'm giving it x, so theta is greater than x with probability 1.
Theta is greater than
Greater
0.
than x.
No? X is uniform 0 theta. So how
Yeah,
theta?
we have an observation small x.
Yeah.
So theta is greater than small x with probability 1.
So you first construct the confidence interval in terms of random variable, right? Not on the observed value. At first, we first construct the confidence interval based on the random variables and the pivot we found, and we use the quantiles of that to achieve our required confidence interval. So that's the method. But once we are having the data, then we put that value to get the actual length or the actual confidence interval.
Can you show your work?
Yeah.
Try to capture my first hint that I have given.
Okay, okay. No, right. Proceed.
Theta you don't know, but for uniform 0, 1, you can
Okay,
easily
so
mention.
okay, so we can take as x comma x plus 1 by 4.
x comma
x plus 1 by
just try to think two different lengths of size of two different confidence two different intervals of size sorry of length 1 by 4, but they two are different. You just considered uniform 0 1. From that you try to figure out two different intervals whose length is 1 by 4, but those intervals are distinct. You can do that.
if I just in uniform 0 comma theta, if I just want to get some two different intervals, then one can be 0 comma theta by 4 and one can be 3 theta by 4 comma theta, but they are depending on theta.
No, confidence interval theta you are estimating, right, by an interval. So
Yes,
the
that's why we can't include that in the interval.
yeah, but the I mean you can't put theta in the endpoints of the confidence interval, right?
Yeah, that's an
Yeah, what's the method of constructing we popularly use to construct confidence intervals? That's pivot. Pivot means I mean something we whose distribution is independent of theta, right? What will be the pivot here? X is uniform 0 theta.
we just have only one observation.
Yeah.
The distribution of x depends on theta.
Yeah. So what's
Try
the
to
pivot?
transform x such that it does not depend on parameter, right? And
Okay, so
pivot
I
includes
take
parameter.
minus log x by theta.
Okay.
Then that will follow exponential 1
Can you repeat once?
minus log x by theta. That will follow exponential 1. So if we multiply it by 2, then it will be pi squared 2.
Okay, so you try this problem better later, okay? Okay. So my next question, now consider one sample. Okay.
Consider.
A sample.
Okay.
I am telling you the PDF of that parent population.
Okay.
Okay. So write fx equal to
Mhm.
theta
Mm.
x to the power
Mm.
minus theta plus 1 minus bracket inside theta plus 1. Okay.
Okay.
X is greater than equal to 1 and theta is positive.
Okay.
Do you know this is which distribution?
This is Pareto.
Right. Now
Okay.
find a two-sided 101 minus alpha, sorry, two-sided 101 minus alpha percent confidence interval based on the sample geometric mean. Denote sample geometric mean by y. Okay.
Mm-hmm.
Denote the sample geometric mean by y.
Okay. So it's we can take like chi-square 2n comma 1 minus alpha divided by 2 log y to infinity.
Can you repeat once more?
Chi-square 2n comma 1 minus alpha divided
Yeah.
by 2 log y comma infinity.
Is that so? I have told you to construct a two-sided confidence interval.
Sorry. So then it can be like 1 by 2n log y chi-square 2n comma 1 minus alpha by 2 to 1 by 2n log y chi-square 2n comma alpha by 2.
Okay, so is that so this is precisely a two-sided confidence interval of length of say confidence with confidence coefficient 1 minus alpha. Now, uh, suppose if I would like to construct this confidence interval, say some 0 comma some quantiles of chi-square and that log y what you have mentioned, something like that. Will that also be a two-sided confidence interval?
Inside it.
Yeah.
I guess no, because that will be one-sided only.
What do you mean by a two-sided confidence interval? Can you tell me?
I don't know exactly the definition. Like if both ends has to contain the pivot or not, I'm not aware of it.
Both ends? Both ends?
I am not aware of if the both ends have to contain the pivot or not.
Okay. So two-sided confidence interval means in any of the one side, suppose the range of the pivotal quantity is from A to B, where A or B may be finite or infinite. On the left side of the confidence interval, you can never put A. On the right side of the confidence interval, you can never put B. So both sided confidence interval should be there, may or may not be the pivot on the both side, but you can't put actually the endpoints of the support of the distribution of the pivotal quantity, right?
Could you
That will
repeat once?
the confidence interval, you on the left side of the confidence interval, okay, you can never put the starting point, say the pivotal quantity, the distribution of the pivotal quantity, the support of the distribution of the pivotal quantity is from A to B. Now, in that two-sided confidence interval, you can never put A on the left side and you can never put B on the right side. Okay. Okay.
Then it's not.
Yeah. Did you get it?
Yes.
Okay. So, suppose if I change the parent population to Cauchy theta 1, will you be able to do that?
We have a sample or single observation.
Sample of size n.
I'm not really aware of this.
So the first step is very, very problematic. That's the creation of that pivotal quantity, right?
Okay.
Here we can't think of any such pivotal quantity as we have done in case of normal or some exponential distributions. That's the problem. So can you really form a confidence interval for theta by small sample size n? Is it possible, or we have to use large sample?
In large sample, we can obviously do the normal approximations.
Okay. So the theta is not the mean of the Cauchy distribution. That's the median, right? So the
Yes.
first thing that should come in our mind that we must use something sort of a sample median, right? For forming up that pivotal quantity or finding the confidence interval for theta. That should be the first step. Now finding the small sample distribution of that sample quantile
Yeah.
is very, very difficult. So we have to go for large sample distributions, right? And out of curiosity, I was just checking your undergraduate syllabus. So where I found a topic called central limit theorem for or central limit laws for quantiles. Do you have any idea or do you remember right now? We can use that.
We were not taught actually. There was something sometimes.
Okay. So we can use that to that's root n sample median minus the population median, that is theta. It actually goes to some normal. In distribution, it goes to normal 0, comma p here. I mean, quantile for p will be half here. It's some sort of pi by 4. You can check. I don't remember exactly the variance, but it will be something sort of like that. By
Okay,
using
I'll check it. Yeah.
criteria, we can do that. Okay. So you can check that formula by which we can construct the large sample confidence interval for theta. Small sample is not possible. Okay.
Yeah.
So now my next question is, we all have discussed these methods. These are methods of interval estimation, right? Okay, and we have done a very, in our undergrad courses, we have done a very little of this topic. We haven't covered very much things and we don't know various methods used here, right? So what we are familiar with is point estimation. Are you comfortable with that?
Yes.
Okay, so consider a sample x1 to xn,
Hmm.
IID from capital F inside small x. That is the CDF of the parent population. Okay. Now, if x is unknown to us, f is not known. I mean, the functional form of f is not known to us. But we know two things about f. First is f0 is equal to 0, right?
Mhm.
And f is continuous.
Okay.
Do you have any idea of survival function? Have you studied it? It is probability capital X greater than X. That is A sub small x. You can write it A sub small x.
Okay.
That is probability capital X greater than small x for any random variable x, right? And it
Ace of small x. Okay.
A sub
It's
small
good.
x. That is
Okay.
probability capital X greater than small x. And we usually define the survival function for non-negative random variables. And that is 1 minus CDF, 1
Hmm.
minus capital F small x, right? So using the sample,
Hmm.
find an unbiased estimator for integral 0 to infinity, right?
Hmm.
Fx
Hmm.
whole to the power
Hmm.
2025
2025.
dx.
The power is on S6, right?
Yeah, s bracket x whole power whole bracket you power just take the power 2025 dx integral 0 to infinity. Can you find an unbiased estimator for that using the sample? And sample size is entirely leave on to the practitioner. Okay, so there is no need to think that there is not enough sample. You have enough sample. You can choose n accordingly to you.
Okay.
I mean, you can take that much is required for estimating this particular integral that I have given to you. Do you need any hint?
I can't really proceed.
Do you need any hint?
Yes.
Okay. So forget about 2025. Say consider 2, sample size 2, right? And take capital M equal to minimum of x1 and x2.
Capital M. Okay.
Minimum of x1 and x2, right?
Hmm.
Can you find probability capital M greater than small x?
This is okay. It's its whole square.
Now can you think about it? That's how you can manipulate the power. But there is two things,
Yeah.
the power and then the integral in front of it.
Hmm. So, if we have 2025 the size of a sample,
Yeah.
and we take the minimum of them, then it will be an unbiased estimate.
Why?
So we can write the expectation of M as 0 to infinity since M is non-negative. So we can write expectation of M as 0 to infinity, probability M greater than X dx.
Did you get
And
that?
yes.
So that's the way, okay? So they may ask you not something of that integral, but they may ask you how to manipulate the power of that CDF, survival function, anything, right? Survival function is nothing but 1 minus CDF. We can define, we usually define it only for particularly non-negative random variables, non-negative continuous random variables. Okay, that's all from my side. Okay.
Okay. Hello, sister. So choose a topic between real analysis and linear algebra.
Yes.
What?
Okay, I could not hear you.
Okay. Do you choose a topic, real analysis or linear algebra?
Linear algebra.
Okay. Write a question. Um, you have a matrix M of order n cross n, and its ijth entry is a random variable xij.
IJth entry is a random variable.
Xij,
Okay.
xij,
Okay.
which is follows Bernoulli half. Okay, and it is IID for any INJ, any cell. It is IID. Okay, so you have to find expectation of date of M. Okay. Okay. So try it and I tell if you need any hint. Okay, don't worry. Can you share?
Mm-hmm.
Can you share in which way you are thinking?
Mm.
I mean, just say in words. You have partitioned them in four part, right? And you are going through expectation, right?
I actually did it for 2
2
cross
cross 2.
2 first.
Oh, okay,
Yeah.
okay. That's fine. That's fine.
And then actually it should be 0 and we can show it by induction, I guess. Um,
You can show it by induction. Okay, try that. But one thing is, uh, for 2 cross 2, it is 0. You are getting that. That is okay. Now,
yes.
think that you have a 3 cross 3 matrix, and if you go through induction, what will you do? You will take first row and then decompose that in.
Yeah, and then like
But
this.
then you have to show that the subpart, when you are decomposing it from 3 cross 3 to 2 cross 2, they will have same nature, same density uh, characteristic, right? Otherwise, how you can take expectation whether they are independent or not? Many things, right?
Hmm.
So what I am saying you that, not one thing,
Okay.
every entry of M will be 0 and 1, right?
Yes.
And as all are IID, then probability of a matrix with only 0 and 1, specific 0 and 1, will be 1 by 2 to the power n square.
Yes.
You get it, my point?
Yes.
So the expectation of date of M will be 1 by 2 to the power n square into summation of all
Possible
determinants of all such
determinants.
matrices, right?
Yes. Yes. Yes.
So go through this path. Okay, so you have to find only sum of determinant of all such matrices, right?
Yes. Yes.
Okay, then you can just, it is that's why I have give you Bernoulli half, right?
Hmm. Yes.
Okay. Can you share what you are thinking?
I was just thinking the determinant to be non-zero, there must be at least one in each row.
Okay. Yes, obviously. Obviously. Now, note some other thing. You have, there are many matrix whose determinant is 0. their sum will not give anything. You have to just
Yeah.
think about non-zero. And I am give you another hint. Write an identity matrix. Okay, 1 0 0 0 1 0 0 0 1. Okay.
Yes.
Uh, its determinant is 1. Okay,
Yes.
and it is a random matrix whose entries are 1 1. Okay. Now, can you do something such that from this matrix you will get a matrix whose determinant is -1?
Yes. Yes. 0 0 1 0 1 0 1 0 0.
0 0 1 0 1 0. What do you do here? What do you do here?
I just actually reverse the order of it. The
Okay.
first row to the third one. Okay.
But can you do something only one operation? Just one operation. You are doing two operation, right?
I'm just like exchanging two rows.
Exactly. So you are exchanging rows two times, two or three times, I think.
Just one times, like the first row
Exactly.
to first and third.
Okay. Fine. Okay. So this matrix has determined -1. Okay.
Yes.
And both matrix belongs to M of M order 3 cross 3. So it is a
Like
hint.
they should cancel out like
Exactly.
this.
Exactly. Can you use this for general n cross n?
Yes.
Okay.
Yeah, if I just exchange two rows, the determinant will also get a minus sign.
Okay. Okay. Can
So,
you?
given like if I have a non-zero determinant, say with one, then I
Okay.
can always construct a corresponding matrix whose determinant is -1. So they will eventually cancel out, and the zero determinants will contribute nothing. So the
Okay.
sum should be ultimately
Can you
0.
write it mathematically? Just one question. Consider that you are working with some matrix A in this case, okay, and you changed two row, okay, and A is you get again A, okay, that will create a problem, right? If you change two row and get again itself, then it will create a problem, right? If you get two different matrix, then their determinant will be plus minus, you will add 0. But if you get itself, that will push you to overcount something.
Then actually that implies that two rows are equal, and that will eventually give the determinant
Exactly.
as 0.
Exactly. It cannot happen. Then it cannot happen. Okay. Uh, another question. Uh, another question from real analysis, right? So you have a function f. It is integrable. Okay. Uh,
Okay.
one minute. Okay. F is an integrable function such that f is from R to R. Okay. And fx plus f of 1 minus x is 1.
Fx plus f of 1 minus x.
F of 1 minus x is equal to 1 for all x. Okay. And then you have to find integration 0 to 1
Mm.
f 2025, f composed 2025 x dx.
So basically f to the power 2025. Hello. I can't hear you.
Ion, your voice
Yeah.
is
No. Okay. So f to the power 2025, f composed 2025. Okay. F of x, f of f of x. You are composing
Okay.
2025. At first, can you give a function such that f of x plus f of 1 minus x is equal to 1?
Is f x equals to x only?
Yes. But you cannot use that, right? Because f is a general function.
Yeah.
From the relation f of x plus f of 1 minus x is equal to 1, try to build something relation for f of f f to x, f composed to time x. Okay. You get it?
F of
F composed to time x, f of 2x. Okay.
yes. F of x is basically f of no, actually if we integrate it, time to find the expression for f of x, right?
No, you cannot find the expression for f of x, right? You will get a relation something. Okay. Here you do not know f, so you will not get anything. Okay, I am giving you another hint. Can you show f of 2x plus f of 2 1 minus x? 2 means
f
in
of
superscript.
2x.
If 2x, yes, 2x means 2 times composed. Okay, here
Okay, f of x, yes.
plus f of 1 minus x
Yes.
is equal to 1. Can you show this?
Yes. Because we can write f of 1 minus x as 1 minus f of x. And
Okay,
since it's true for all x, so we can do that.
okay. Now, what can you do from this?
Hmm. This is basically true for any composed
Okay,
order.
exactly. Now, can you use
So
this to find the integral?
yeah, we can write 0 to 1 f of 2025x dx as 0 to 1 f of 2025 1 minus x dx.
Okay, okay.
So if I write it as I, 0 to 1 f of 2 and add them,
Okay.
that will be 1. So 0 to 1 dx equals to 2y. So I is equal to basically I by x by 2.
I will
That's
be x by 2.
sorry, 0 to 1. There is a limit. So it should be half.
Okay, can you show on your script?
Yes.
25x. How you are writing 0 to 1 first, how you are writing the first line? F of that is equal to f of 1 minus x.
So actually, I studied it as a formula for definite integral.
Uh, can you prove this?
And
Why
I can
you
try.
so one thing is in interview don't say something okay like this because this is very fundamental, so just try to prove this
I
in
can really hear you.
okay. I am saying is that do not say something like this that I have studied it as formula. Okay, uh,
Okay, okay.
okay, just give it 1 or 2 minutes to prove this. Okay, otherwise it is fine.
Hmm. If I consider this as g of x,
Okay, give the definite integral. Okay. Okay, so you get it right.
Yes.
So yes, in interview just show these things. Okay, otherwise fine. Okay, so it is half. And another suggestion is that in the previous problem, where you just add determinant, those are zero, you are saying that thing, try to prove those part with such argument with I is equal to sum, then you are taking it I is equal to minus I, then I is equal to half, or I is equal to zero. Okay, do it later. Okay,
Can you
you get
please
my point.
repeat once? Like I could not
I
get
am
it
saying
clearly.
that, okay, I am saying that we have to show that sum of all such determinant is zero, right? So proceed, start with I is equal to sum of all determinant, then determinant is equal to minus determinant, then you will get I is equal to minus I, then 2I is equal to 0, then I is equal to 0. You get it? Just write it mathematically in later. Otherwise everything okay. Okay, I am done. Thank you.
Okay,
Jit.
so yes, yes.
Okay.
So am I audible?
Yes.
Hello.
Yes.
Okay, so my question is to you. Suppose there is a pond, okay, and there are some number of fishes. Suppose there are capital N number of fishes. Okay. So my question to you is, how can you estimate the number of fishes in a pond? Hmm. You can take sample according to you. Okay.
Yes. So, if we
Yes.
just catch some fishes
Hmm.
and like uh, by spreading the net all over the pond, then and we
Hmm.
if we consider that every fish will be caught in the net independently with probability half, or say
Okay.
probability, yeah.
Every fish. Every fish. Okay.
So then the number of fishes caught will follow binomial, capital N
Okay.
common.
Will it follow binomial? Because if you are like, suppose you catch a fish. Okay. Suppose you caught the
Yeah.
first fish. Then will the number of fish will be the same? Like, suppose there are capital N number of fishes. If you catch the first fish, okay, with probability half, and uh, when you try to catch the second fish, then what will happen? Will the number of the total number of
Actually,
fishes will be the
technically,
same?
it
It will
should
be n
not
minus 1.
follow, should not be
Okay.
independent, and like every fish does not have a probability of getting caught with
Yes.
half.
Yes. 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 So yeah, you are in the right track, but just formulate it like try to formulate it. You don't have to estimate it unbiasedly. Okay, so you don't have to estimate it unbiasedly. You just have to estimate.
If we catch a certain number of fishes, like
Yes.
we can always propose an estimate like 3 into n or something like that. But that's not really.
Like you have to give some logic. You have to give
Yeah.
some logic that why are you proposing that kind of estimate. Okay. So don't think that you have to take only one sample. You can take two, you can take like many times.
In fact, you are allowed to take a lot. I mean, in a lot, you can, in a bunch of group, you can take one at a time, you can draw a sample, right? At a time, you throw a net and you can get a sample from that.
Yes. So what I was making wrong in the binomial is it should be hypergeometry.
Yes. Yes. But to like there should be some success probability, right? Like there should be some p, some proportion.
Yes.
So I just told you that there are some number of fishes. Okay. I have not told you any type of proportions or something like that. So can you propose like how can you get some proportions from it? You have to take a proportion, right? There should be some
Yeah.
p. So can you do something for that?
So if I first take a sample
Yes.
and then like I have say smaller number of fishes
Hmm.
and I'm taking the some success probability for each fish to be p.
Each fish is p. Okay.
Like each fish will be caught with probability p.
Okay.
If I take that to be constant for all fish.
Yes. Okay.
Then using the small n, I can get an estimate of p for this.
How can you get an estimate of p from this small n? Like what will be your p? You are just catching some fishes, right? You are just catching. You don't know capital N. So how can you get the proportion? Okay. So do you need a hint?
Yes.
Okay. So you can at first take a sample. Okay. Suppose you at first take a sample of size n1. At first you catch them. Then tag them. Tag
So
all the
like
fishes.
it's not like that I don't know the sample size. So I will catch the fishes until I get
Yes,
n1 number
yes.
of fishes.
Yes, 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 yes. You can. No, you are taking like suppose you are throwing a net and you only catch like small n1 samples. Okay.
But the number
You
of
can
fishes
take,
is also caught is also a random variable, right?
but you can fix them. You can fix that. You can fix that. Suppose you need 3 or 4 fishes. Okay. So catch 3 or 4 fish from the pond. You can do that. Okay. Now suppose you tag them. You have tagged them, like you give some mark on them, and then again release them in the pond. Okay. And then you take a sample. Now you have a proportion, right? There are two
Yes.
types of fishes. There are two types of fishes, which are one of them are marked and other of them are not marked. Now take another sample. Now can you formulate, like can you uh,
Yes.
give something? So how are you estimating this?
So in first sample, say I have got capital M fishes and tagged
Capital
them.
M. Capital M. Okay. Okay.
So, and then when I'm taking the second sample, say X denotes the number of tagged fishes caught in the second sample.
Second sample. So how many, like
Of size small n.
how many fishes are there in of size small n? Okay. Okay.
Yes. Then X follows hypergeometrics capital N, capital M, small n.
Capital N, capital M, small n. Okay.
And so expectation of X would be capital N by capital N into small n.
Capital N by capital M. Capital M by capital
N
N.
by capital N, the proportion.
Okay, yes.
Into
Yes,
small
the
n.
proportion into small n.
So M and all quantities are known here. So like
Okay.
X
Yes,
by
you know X,
capital
you
M.
know, yes, you know X, you
M
know
by capital.
capital M. You just have to do that. Okay, you can estimate in that way also. Now, suppose I want to get the MLE, maximum likelihood estimate. So how can I get that? So at first, tell me, like from the sample strategy that you have, what will be the minimum number of fishes in the pond? What will be the minimum number of fishes?
Capital M.
Are you sure?
Well, after I get the second sample, it
sample.
should be maximum of small n, capital N.
No, there can be like, suppose at first you have taken 5 samples, and in the second you have taken 3 samples. Okay. And what will be the
there I
minimum number
can
of?
find the number of untagged fishes in the second sample.
Yes. Yes. So what will be that? What will be that? So what will be the minimum number of fishes in the pond?
It should be capital M plus small n minus X.
Yes. Capital M plus small n minus X. Okay. That's perfectly fine. Now try to write the likelihood and try to maximize it. Tell me the form of the likelihood at first.
It's capital M small x, MC small x.
Okay, MC small x.
Into capital N minus MC N minus small n minus x.
Okay.
Divided by capital NC small n.
Capital NC small. Okay, yes. Okay. And what will be the support? Like, what are the values that X can take?
So X is greater than equal to 0 and less than equal to minimum of capital N small n.
Okay. Will the lower bound will be always 0, or can it be greater than 0 or less than 0?
Small x.
Yes, small x. I'm asking you, what is the parameter? Like, what is the parameter here? What is the unknown quantity here in your likelihood?
Capital N.
Capital N. So,
X is
like,
greater
will
than
the okay, so
N plus.
Okay, so will the support of X will not depend on the parameter, or is it independent of the parameter?
Yes, it should be greater than M plus small n minus capital N.
M plus small n minus capital N. Yes. So no, not only that, like it will be maximum of 0. Like it cannot take a negative value. So if capital M plus small n minus capital N is a negative quantity, then X cannot take
maximum of 0 and this thing.
0 and this thing. Okay, now proceed.
So I'm trying to find L of n plus 1 by L of n to see if it is
Okay.
increasing or decreasing.
Okay.
Can you tell us how are you approaching to find the maximum likelihood for n, maximum likelihood estimator for n?
I'm trying to find L of n plus 1 by L of n to check if
Okay,
it is increasing in n or decreasing in n.
okay. So this method is a quite popular method for that's used to find one important property of descriptive statistics that we have learned in descriptive statistics for discrete random variables. Can you name that property?
Descriptive statistics.
Not descriptive statistics, I'm sorry, that is actually central tendency.
In
Central tendency for discrete random variables, there is a measure of central tendency where we use this type of method that L of n plus 1 by Ln to find a particular
yeah,
measure.
so in binomial we use to
Yeah, but what's that property? Property means what that central tendency is.
okay, so the mode.
Yes.
So it is decreasing in n.
Okay.
And from there we found that capital N is greater than m plus n minus x.
M plus n minus x. Okay. Okay,
Capital
for the
N
property.
smaller.
Okay. Yes. Is it always decreasing in n?
Like small n of capital N plus 1 by small n of capital N. It's coming out to be like this.
Okay, capital
So
N
this
minus m plus 1 into capital N plus 1 minus, what is it? Small n.
small n, yes.
Okay. Into capital. Oh, is it always decreasing in n? Like what? Like
This
what is
part
the
is less than
function?
1,
What is the parameter here?
capital N.
Okay, so is it always decreasing in n?
This is the ratio. So
Yes.
this part is less than 1.
Hmm. Yes. And what about the other part?
Yeah, because x is always less than equal to capital M.
X is always less than equal to capital M. Yes.
So this is basically n plus 1 minus small n plus x minus m. This is positive.
X minus m. That is negative. X minus m is negative, no? X is always less
Oh,
than m.
sorry.
So is
Yeah.
it always decreasing?
Okay, so this is also less than 1. This is minus n plus 1 plus x minus n. Okay, no, we can't say that.
So what can you do after this? You're on the
So
right track.
we can
Yes.
find an expression when it is decreasing.
Yes. So get that expression.
So for capital M greater than capital M into n minus 1 by x minus 1
Capital M into n minus 1 by
divided
x
by
minus
small
1.
x whole minus 1.
Okay, when n is greater than, or n is less, or what are you saying? N is greater than or less than?
Yes, when n is greater than this quantity, then the likelihood is decreasing.
Okay, so can you show me your copy?
Yes.
You are getting capital M into small n minus 1. There should not be -1 here.
Okay. Oh, this cancelled out. Sorry.
Yes. Okay. So what is the MLE then?
Name like so when in this together and then that's it. This I got to go to the decrease by one this one I take away decrease picture. So yeah,
So
this
what will be
should
the MLE?
be MLE.
Mn by x. Okay, that's perfectly fine. Now suppose I want to find the MLE of suppose e to the power n. Then what will be the MLE?
Then it should be to the power box of this
So
is a
what is
one
that property?
function.
Okay, so what is it is called? What the property is called?
Not really sure, but it is the invariant property or something.
Yes, 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 yes. Invariance property. So will it always hold for MLE? Will it always hold?
If the function is 1-to-1, then it holds for sure.
So if the function is not 1-to-1,
Like actually, okay. So in general, we write it for any continuous function, but I like if the function is not 1-to-1, then the concept of MLE kind of
what like
I'm telling you, like suppose the function is many to one.
hmm.
And for values of x.
So tell me intuitively, like you don't have to write it mathematically. Tell me intuitively,
Yeah,
what will
so
happen?
when like two values of x may give
Yes,
one fx value,
one of x value.
two distinct values. So from like we are considering two only here, and suppose
Hmm.
one of them is the MLE and the other is not the MLE,
No, it's
since
not.
they are
Yes.
distinct.
Hmm.
Okay, so yeah, still that value of fx is maximizing.
This will
Yeah,
maximize the
This
likelihood,
is,
right?
yeah, yeah.
Yes. Okay, so now my question is like suppose I have a sample of size n. Okay, suppose x1, x2, xn is a sample from a distribution like IID sample from fx distribution fx. Okay, and
CDF.
y1. Okay, like you can take anything like that
Okay.
doesn't matter. fx the
Okay.
parameter is theta. Suppose the parameter is theta. Okay. Then I have taken another sample independently. Okay. Suppose y1, y2, ym are also a random sample from that same
The
distribution. Okay.
size is same.
Yes.
So the
No, no,
size
the
is
sizes
same.
are not. The sizes can be same, can be different.
Okay.
Doesn't matter. Okay.
I'm taking it as
Now, now suppose I have given you the MLE. Like suppose theta one hat is the MLE of theta for
y1
the
minus
first sample.
ym is the distribution norm.
Yes.
Like
Suppose the
x1, x2.
distribution is known.
They are IITs,
They are from
but
the same distribution.
some G
They are from
theta
the
actually.
same distribution. Okay.
Okay.
Now, suppose theta one is the MLE for theta one hat.
Hmm.
Suppose
Hmm.
MLE for theta for the first sample, and
Hmm.
theta 2 hat is the MLE for theta for the second sample.
Hmm.
Now suppose I am claiming that theta 1 hat plus theta 2 hat by 2. Will it also be the MLE for the MLE of theta? Because using invariance property, can you tell that?
Correct. But if I consider the combined sample,
Yes.
so there the likelihood function has now changed.
Yes.
It is L1 X curl into L2 Y curl.
Yes.
So they're all IITs.
They are all IIT.
Basically, the two likelihoods are being maximized at two different points.
Yes.
With the combined. Can you say something about the combined?
Yes, like what are you trying to tell?
So your question was like, if I can tell that
Yes,
theta 1 hat plus theta 2 hat by 2 is an MLE.
is an MLE. Like, can I tell that? Or it will never hold, or it will hold for everything.
It should not be true generally.
Generally. So can it be true for some cases?
If the that will depend on the values of the samples.
Values of the samples. Like, can you give an example?
Maybe observations.
Can you give an example?
Suppose I am taking like Bernoulli trials,
Okay.
and for maybe in all observations are one
All
in both
observations
the
are one. Okay.
samples. So then it holds, right?
If all the observations are one,
Theta 2 hat
like,
are
will MLE exist? If for a Bernoullian trial, suppose the parameter space is open 0, 1. If all of the observations are one, will MLE exist? So give me a simple example, like from normal theta 1. Suppose you are drawing samples from normal theta 1. What will happen? Suppose fx is normal. Okay. What will happen?
So we might okay. So there theta at MLE is x bar.
Theta ML is x bar. Theta
And so
1
if
MLE basically. I have given you theta 1 and theta 2. Theta 1 hat and theta 2 hat. We have two samples. Okay. You have two samples.
yes, but the parent distributions are same.
The parent distributions are same. Yes.
So
So you have two samples.
yeah, the MLE is x bar.
ML is x bar
Like
for the first sample.
Sample mean.
Yes. Yes. First sample mean is the ML for the first
And the two
sample. Okay.
sample means may be equal.
If the two sample means are equal, then will this
Then
hold?
it's hold.
Then it will hold. Yes. Yes. If the two sample mean are equal, then it will hold. Okay. So if they are different, then
Like x bar plus y bar by 2.
What do you think? Will it hold or will
Yeah.
it not?
No, it
Or
won't.
will it?
Because if I
Hmm.
consider the combined sample, LX third,
Yes. Yes.
that should be, like, I'm telling the first likelihood function
Okay.
as
Okay.
L1 and the second
Okay.
as L2.
L2. Okay.
So L1 theta 1 hat plus theta 2 hat by 2.
L1. Okay.
That's
L1 theta 1 plus hat plus theta 1. Okay. Okay.
that's obviously less than L1 theta 1 hat. So theta 1 hat and theta 2 hat are different because it is
L1
being
theta 1 hat.
maximized at theta 1 hat. Right?
No, for the combined sample, that
I'm
is the
talking about
question, na? Like,
L1 only.
okay, L1 only. Okay. Yes.
And
Yes.
similarly
Okay.
for
Okay. Okay. Okay.
L2,
Got it. Got it. Okay.
if I
Similarly
just
for.
multiply, yeah. So
Yes,
I'm
but that
getting,
is. Yes, but I am asking about the combined sample. You are talking about the L1, like L1 theta 1 plus theta 2 hat by 2 is less than equal to L1 theta 1 hat. Okay. Now L2 theta 1, like L2 of that average is less than equal to L2 of theta 2. Right. You are claiming that.
yes.
But what about the combined sample?
So, guys, it's already having 2 hours. So, please conclude the all thing.
Okay. 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 So I'm giving you a hint, like if the sample sizes are same, okay, suppose M and N are same, then the MLE of the first sample will be what? If MLE of the first sample will be X bar.
Hmm.
The MLE of the second sample will be Y bar.
Hmm.
Okay. And what will be the mean of the combined sample? It will be N into X bar plus N into Y bar by 2N.
Like one.
So that is basically theta 1 hat plus
Okay.
theta 2 hat by 2. Yes. So if the sample size are same, then it will be an MLE.
Yeah, yeah.
And of course, the MLE should be linear in parameter. Okay. Should be linear in parameter. Otherwise, you cannot claim this, because if you draw a sample from uniform 0 comma theta, then what will be the MLE? It will be X order n, the largest statistic,
Hmm.
and you draw another random sample independently, then it will be Y order n, the largest Y order m, the largest order statistics, and if you combine them, then it will be the combined mean, combined maximum basically. Okay,
Hmm. You can't
so
really
that
say.
so that is the condition, and invariance property will hold if you fix a sample. Okay, to fix a
Hmm.
sample, then only this invariance property will hold. If the
And
sample size is
invariance property, we really need continuous function, as you have first mentioned 1 1, then you have rectified it to continuous. Do we really need continuous function for that to hold?
No, any function will.
Yeah, any function will work. Okay.
okay. So that's all from my side. Do you have any question?
How was my performance?
Your foundations were very clear and your basic concepts are very well. So no need to think about that. Just try to, just try to be confident there. And if you stuck at any point, ask the professors of ISI Delhi. They will surely help you out. Okay. Just be confident and try to think. They will suppose they if they start with some problem, they will first clear check your basics, then they will go depth into that. So if they ask you something and you got stuck after their hint also, if you can't think, then don't think anything that is out of the scope of that particular problem. Okay,
Hmm.
questions are usually within, they will be within that problem something, so don't need to think very much outside of that problem. Okay, usually they will not be doing that.
Like if you are going wrong, then they will give you a hint and they will like take you back to the right track. Okay. So
Yes.
try to capture the hint that they are providing. Okay. Try to think about them. Otherwise, your basics are very clear. And you can build that. You can build that. Like you don't have to solve a lot of questions. Just think about the definitions, think about the basics, and try to build upon that. Okay. So you
And
don't.
you were able
Yes.
to capture our hints very well, so we are sure that
Okay.
if you
You
listen
will
to
do
them,
well.
carefully and confidently, I'm sure you can build up the problem.
Okay.
Okay. All the best.
Thank you.
Yes, best of luck.